I had wanted to, what I'm going to do now is I'm going to rewatch. It's one of the Energy from the Vacuum series in which John Bedini talks about Tesla's switching circuit. And I'm kind of gravitated towards that video because, I don't know, for some reason it's so appealing in the overall simplicity of its design. The concept behind it is utterly simple. The proof of concept is so simple. The execution was something else, as if you've seen the video, the DVD, you'll know what I mean. Or else Ron Cole would not have had transistors blow up on him and go to John Bedini to figure it out, work it out, which he did. What I'm guessing is, what I was started to guess like a day or two ago was, well, how would you take out the batteries and put in capacitors? I don't know. Would you want to? Well, I've come to the conclusion that the idea of shorting out, putting a divider between a shunt divider between the source and the load, have two different circuits that are connected in parallel with the short causing there to be a parallel connection. And then somehow engineering it so that the load has less resistance, far less resistance than does the supply branch. So that, and if the generator, and if the supply, strictly speaking, provides a dipole, I guess, proof of concept would be very straightforward. You'd simply have a DC battery situation, or even just an AC generator, creating that dipole. But you'd have to arrange it such that the supply branch has very high resistance, internal resistance, keeping the amperage way down, so that it's almost non-existent or nearly so, yet the voltage be maintained at the very least, if not boosted. Obviously that's a consideration for AC. Anywho, while on the load branch, the only resistance is the magnetic resistance of the coil within the inductive load, for the most part, or for the only part, so that there's almost no resistance by comparison. It's a comparative thing, proportional balance kind of thing. Well, in considering that, I thought to myself, okay, now, what's the interface, though? Conceptually, it's a short, but it's got to be something more than that. And so when I was thinking it over, I thought to myself, well, what if because the supply has to be DC. That's my guess for the moment. Or I was trying to think in terms of DC, let's put it that way. And I thought, okay, so that means, no, I was trying to apply my prior design. I haven't posted it yet because it was very difficult, so I thought, okay, the latest design of what I'm guessing Tesla's trimetal generator was basically a tank circuit, but a little different in its, a little unique in how it's built. But basically a tank circuit, which makes it AC output. So I thought, okay, in order to be a DC output, you'd need a full bridge rectifier. And I thought to myself, okay, after the full bridge rectifier, or at it, since I didn't draw it out, I don't know which, that's where the shunt occurs. And then I thought to myself, no, wait a minute. What if we take the final design of Bedini's development that he showed us on that DVD of Tesla's switching circuit, and use that as the buffer zone between the supply and the load? Now, in a sense, his switching circuit was an AC circuit, but of course it was a very slow switch cycle. And in any event, he had his sets of batteries, DC batteries, funding each half of the circuit as it bounced its energy back and forth in AC fashion, but it was powered by DC ultimately. So I was thinking, okay, if I'm designing a tank circuit, oh boy, this sounds complicated, which is AC, then it's bridge rectified to output DC, then that one unit becomes one of the 2 to 4. I think it was 4 units in Bedini's circuit that were alternating, but I can't remember now. 4 batteries, but grouped in 2. Oh, they were in 2 pairs, that's right, because there was parallel versus series connection on both sides. And that made, yeah, it was to duplicate the 3 battery setup of proof of concept, in which 2 are oriented one way in series and the third one in series is backwards. So he developed a 4 battery system, but it was a 2 split. The circuit was split into 2 halves, and on each half he had both. One battery was connected in parallel to its half, and the other was connected in series, and for some reason that worked a certain way to the advantage of the design. But it was still 2 halves that were alternating back and forth, shooting energy back and forth to the other side, or something like that. Might have been actually it was to 1 battery at a time. So it might have been going around in rotation at a 4-part cycle. I don't know. I can't remember. In any case, I was thinking to myself, okay, what if each battery is replaced by the so-called tank circuit arrangement that I was considering on my latest design, but I haven't posted yet, because it has the full bridge rectifier to turn it back into DC, and then so the tank circuit's got 1 frequency, it's operating AC, but then the switching circuit has another, and the DC in between, and and this is the buffer between the DC battery and the DC load, because that's what I was originally considering. How would we make this work for a DC load? So it's like it's going through AC twice with, oh my god, talk about convoluted. But my intuition is this is it. This is how to do it. That Tesla special generator has to be plugged in, shall we say, into a larger context to start to make sense. And if it's plugged into the switching circuit of Tesla's switching design concept, then it starts to make even better sense, because it's not trying to carry the weight of the load all on its own shoulders. It's doing so with assistance from another technique that Dort Jr. did not share with William Line. And it's a big piece of the puzzle. You know, when you've got a multi or a complex circuit made up of various conceptual segments, and this being at least 2, then actually 3 at this point: tank circuit, switching circuit. No, it's just 2. Tesla's tri-metal generator as a tank circuit feeding a switching circuit. So it's 2 main conceptual design characteristics. Because I feel the switching circuit is what's going to make Tesla's tri-metal generator operate as a interface device between the switching circuit acting as an interface device to interface between Tesla's tri-metal generator and the load. Because by itself, the tri-metal generator concept is lacking. Anybody notice this? You know, it's why nobody dwells on it. It's so seemingly lacking in whatever fundamental concept would make it seem to carry itself forward, and actually provide a service. You know, it's like a maid who comes to work at your house, and she comes with a mop, but there's no soap. Well, I could have done that myself, you know. You at least could have come with the soap. So, you know, what's the point? Or the soap arrives without the maid. Well, Well, what am I paying you for? Not the soap. I want you to do it for me. Anyway, you get the point. There's kind of a minimum building blocks needed, and the trimetal generator storyline is insufficient. It just doesn't give us enough information, and it could be because it's simply describing a subcircuit of an overall circuit that has another circuit plugged into it, at least one other circuit plugged into it to make the whole thing work. Now, by itself, Bedini's switching circuit, as it stands, what he presents, works. You just put in batteries, and it works. But we know Tesla's trimetal generator had nothing to do with batteries as its mock-up. If anything, we had a reciprocating piston that William Line had been promoting the idea of. So, a vibrating reciprocating piston. So that there's this stuff missing. And when you think about it, maybe that reciprocating piston is nothing more than a switching circuit. Oh, ooh, I like that. Very much higher oscillations, though. But so what? It's efficient. And most importantly, it solves the problem of how to do it without a transistor. Transistor didn't exist in Tesla's day. So that's how he did it. By the use of a reciprocating piston to serve as the switching circuit. Oh my God. Wow. Oh, that's heavy. That is really heavy. That is so heavy. Oh, I'm glad I turned on my cell phone to do this video. It always helps to talk about it. My goodness. When people want to shut me up, I don't let them anymore. I let my mother get away with it. Only because she brought me into this world and gave me life. But I don't let anybody else do it because it's the most stupidest thing in the world. I knew she was insecure. I knew her excuse. Single parent. She was afraid her authority would be diluted. Nothing of the sort. I was simply providing constructive criticism to help improve her performance as a parent. She was obviously needed help. She was stressed out of her gourd. But I guess she was too stuck up to get help from the very child that she was trying to raise. Too stuck up. And this is what dictators like, micromanagers. They want all the power to themselves. So they shut you up. You can tell micromanagers from the rest of the crowd, they got to shut you up. Because they got to have all the power and authority to be the only one speaking. The only one to have any position of influence in the course of the discussion. Anywho, it's another topic, but it's very much on my mind because there's something else going on, and it's very much on my mind. But I needed to do this because this came during meditation, and I thought it was significant. So it's good talking about it. It helps. So that's the purpose of the reciprocating piston. That is the switching circuit, or the heart of it, at any rate. Because you need in Bedini's version, he's got a timer chip, and he's got transistors surrounding it, so, diodes, so, some of those stuff didn't exist in Tesla's day, but these are concepts, and there's always a workaround solution, just like in math. If you don't have modern components, you use the earlier ones. No problem there. Tesla always pulled it off. So, I guess then we can give ourselves permission to give up the compressed air driving the reciprocating piston because Bedini provided it already in his switching circuit. And he said he had another version, which, I don't know, did he say it was proprietary in that DVD? I can't remember, so he couldn't share with us what it was. But he showed us, though. He didn't share he didn't describe what it was, but he did. They put in another segment on that DVD of a later taping. They went back to his shop, and he showed them a very more advanced version, and it was solid state. There was no moving parts, no relays, nothing. No, what was he using? What do they call it? Optical relay solenoids or optical relays? Because he needed some way to be switching. Well, where's the switching going on? And so, although they were although they were probably the best version of a switch or relay that he could have used in a simple device that he could show us. The other one he didn't. I don't think he described it. He allowed the photographer, the cameraman, to pan the circuit board, show that, oh yeah, to vindicate, oh yeah, Bedini did it, but not really tell us what he did, because he said in the first episode, I have another, but I can't describe it to you for various reasons. So yeah, okay, but still, however advanced, it's still just the interface between the portion of the trimetal generator that generates the energy and the load that burns it off. So the switching circuit is the interface in between the two. And that can or could provide the conceptual framework for the so-called short that I have been referring to. Functionally speaking, it may just functionally provide it in its own way, the short. I'm not sure yet. Because just a simple short, come on now, It might be fine for my sleep circuit as a point of inspiration, but that far no further. And it does that go? Does that idea go? It's got to be a little more sophisticated than that, a little bit more. So it could be the switching circuit that serves that purpose. Because the purpose of the short is to act as the interface, to appropriately set everything up so that you get a voltage buildup on the supply side and a current buildup on the load side. That was the whole point. That's the purpose of that shunt concept. So if the switching circuit does that, then it serves the same purpose, but it does so appropriate for the circumstance, though, of trying to wonder, well, how do we replicate Tesla's trimetal generator on so little information that was given to us? So now we know the reciprocating piston is the heart of a switching circuit. I thought it was something else initially, that's nice. But see, the only way I can say this now is because Bedini has given us an example. It's all because of him. No skillfulness on my part, just the teeny weeny skillfulness to recognize. Again, it's like a repetition. I've already done videos on this. Bedini has the answer. So this is the heart of it, though. And this is what matters. But nobody's come out, and he didn't come out and say, this is the replication in a modern version of what the reciprocating piston idea that William Line talks about. He never said this. I mean, and I suspected that he had very strong reasons not to say anything. Because I think I hedged myself in that earlier video of about a year ago, in which I said either he already knows or he could know because he's got the knowledge base to make it work, to figure out how it works. If somebody asked him, and I never asked him to work on it or to tell me if he thought he knew how it works. I never asked him, and probably that's my failing. But I knew when we heard that he passed, that I knew in my heart that it wouldn't matter. The realization would come about anyway, and I could see why. Because he's given us so much, it's just a question of figuring out if any of it applies, and now I think it does. So, but still, this is just vague thinking. I haven't put it down on paper to actually look, or just, looked at. What I'm going to do is rewatch his video, is what I'm going to do. The Tesla switching circuit video. And see if my idea is vindicated that the switching circuit is the heart of the interface between the supply and the load, but still doesn't explain the structure of the supply. I'm just guessing that it's in the format of a tank circuit. I might as well say what it is. It's a coil, an iron insulated coil wound around the capacitor of that tank circuit. And the capacitor is a multi-plate stack of copper discs with whatever dielectric in between them and surrounding them. And that capacitor stack, a column of many, many, many stacks, I was imagining, is inserted into a aluminum tubing with appropriate dielectrical insulation between the copper stack and the inside surface of the aluminum tubing. So there's dielectric in between each copper disc or plate disc, as well as dielectric in between the whole stack and the inside surface of the aluminum tube. Around this aluminum tube is then wound the iron wire with its insulation, very long length of wire, John Newman style, quite possibly, because William Line does say that in his storyline, the interview actually with Paul Scarvo, I can't remember the guy's last name, 33rd parallel excerpt, and that winding is connected in parallel to the stack, the copper stack. The aluminum tube is a floating plate of one of two plates of a capacitor, the other plate being another aluminum tube large enough to fit around the whole entirety that we have so far. So we got the coil of winding wound around the aluminum tube, inside of which is the copper stack. And so the outer aluminum tube is the chassis, so to speak, of the whole device, but it's also serves as the second floating plate of the capacitor, which is the coil in between. So the coil is immersed in the dielectric because the coil is slathered with additional dielectrical material, not just the insulation around the wires. And so we literally have a capacitor fueled not by the plates being connected to anything, but by a coil being inserted in the midst of the dielectrical sandwich between the two floating plates. And this, I think, satisfies the E.V. Gray motor approach to creating a capacitor, in which the way Mark McKay describes it, to me, if I'm not mistaken, it sounds like both functioning plates of that capacitor, one being the chassis of the E.V. Gray motor itself, and the other being certain supporting structures, I think for the, the rotors or the stators electromagnets on the inside. Those were aluminum parts, and those were the floating plate counterpoise to the chassis, and the chassis was lined with Teflon on the inside. So those two floating plates are both those two plates of that capacitance are both floating plates, and it's the coils that are charging them. And their dielectric surrounding them is the air that is flushed through by the help of a compressor to prevent arcing. But in my situation, I thought, well, maybe we don't need to go that route, especially if we're trying to go the route of solid state, and then the reciprocating piston has to go out the window somehow. Now we know how. John Bedini's solid state switching circuit. But so the coil then has to be slathered with dielectric of some, could be Tesla's, recipe that Mark McKay gave us. Beeswax, pine rosin, and 5% carnauba wax, whatever it is, So, me, I when I did an orgone wrapping, I used natural shellac on rosin paper. That was my version of coming up with a natural source of resinous material to help improve the characteristic behavior of the device, the orgone device, bringing in more energy from the ether. But, Tom Bearden said that. All we have is a dipole, a voltage dipole, and the amperage comes in from the ether, enters the circuit, and kills the dipole. So the current is never supplied by the battery, as an example. The DC power source does not supply the current. The current kills the DC power source. So the current enters into the circuit from the ether, which is not part of the circuit. That's the extra ingredient that we never figure into the course of analyzing a standard, conventional electric circuit. So let's see. So I've covered that part. So I've described it without using visuals, with my eyes closed, no less. If you can imagine what I just described. But, yeah, I was going to do a whole PowerPoint, but it's so much work. Oh, God. And I don't have a tablet. I could be doing drawing, while I narrate, but I don't have a tablet, sorry. That's has not been on my priority of things to buy. So I think this is significant. The Tesla switching circuit is the shunt, is the short that serves as the interface between the supply and the load. And I just described the supply and the structure of the three metals involved. So I pretty much described the whole thing, conceptually at any rate, in a vague sense, without using any visual aids. So it either works or it doesn't work. It's not a self-starter. It's not intended to be. Some means would have to be found to get it going. I imagined a little assistance on the load side, a starter motor on the load side. Or you just hand crank. If you've got an inductive load, you hand crank it. But there's nothing about this that looks to me like a self-starter. No, I'm wrong. I'm wrong. The switching circuit is a perpetual self-starter. Yeah, because by itself, the story that we're given about Tesla's trimetal generator is like, what keeps it going? Oh yeah, the reciprocating piston. Well, there you go. It's the switching circuit that keeps it going. So it not only provides the interface, but it keeps it going. The interface between supply and load, but it keeps the interface going. It keeps it lively. Because if it's not lively, the whole thing goes dead. So there you go. So Tesla's trimetal generator is both a substitute for traditional sources of energy, such as a battery or a generator, a traditional generator. Creates no back EMF, right? No, the back EMF is part of the circuit. That's right, a tank circuit. Well, yeah, you could say the back EMF, except the back EMF is equal to the forward EMF, so whatever. Or semi-equal. Anyway, you utilize all of it, so there's no waste. So you're not trying to remove back EMF. It's just part of the circuit. That's the nature of a tank circuit. It bounces back and forth, ding, 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 creating an AC effect. So it's very interesting. But it's funny, though, to take that and obliterate that AC characteristic by passing it through a full bridge rectifier in order to use it in the context of supplying a DC-driven switching circuit, which ultimately becomes AC all over again. So it's like, wow, this is weird. Well, it's not unlike Tesla to do a weird sequence. It could be. Maybe. Could be. But of course, in today's age, we would just put a battery in there. But the battery will wear down. Didn't? See, there was another storyline that said he had a generator that would last 5,000 years with no moving parts. So what he gave the Nazis, of course, is not exactly that. By far, not at all that. So he had a solid-state version of his own device. What am I thinking? What was I... Oh, God, what was... I had it there. Anywho, whatever the thought was, I lost it and I forgot what it was. So I think I've spent all my ideas. So I think that's everything.